Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry, and here we have the topic that is angle between a line and a plane, right? So here we have a problem. If the angle between the line x plus 1 over 2 equal to y minus 2 over 1 is equal to z minus 3 over minus 2, and the plane x minus 2y plus kz is equal to 3 is cos inverse 2 root 2 over 3, then find the value of k, right? Now viewers, we have already discussed the concept of angle between a line and a plane in our previous classes, but here just for the sake of new learners, we can take up the concept again, right? So let us take the rough diagram of a plane, and here we have this plane pi, right? So we can denote the plane by pi, and we have this plane x minus 2y plus kz is equal to 3, right? Okay, now let us take the normal to this plane pi, right? Suppose this is the normal vector to the plane pi, and this is denoted by vector n, right? Okay, so now the normal vector is a very important component of a plane, and here let us take the line like this, right? Suppose this is the line, and we have to find the angle between this line L and this plane pi, right? So let us denote this line by this letter L. So we have the line x plus 1 over 2 is equal to y minus 2 over 1, z minus 3 over minus 2, right? Okay, now if we take a line like this, then we see that if we take this angle as theta, then obviously this angle would be 90 minus theta, right? So the angle between the line L and the plane pi is theta, but in three-dimensional geometry, what we do, we take the angle between a line L and the plane pi as the angle between the line L and the normal vector vector n, right? So the angle between a line and a plane is treated as the angle between a line and the normal vector to the plane pi. So now the angle between the line and the plane is considered as the angle 90 minus theta and not as theta, right? So now let us denote this angle 90 minus theta by the letter phi, right? So now phi is the angle between this line L and this plane pi, right? So which is same as the angle between the line and the normal vector, right? So now we have to find phi, and we know that there is a vector which is parallel to a given line, right? And the vector is given by the dr's of this line, and let us take the vector like this, right? So suppose this is the vector b, and this vector b is always parallel to the line L. So now this vector b, which is parallel to this line L, and which also gives the direction ratios of the line L, is given by these three numbers, right? Provided the equation of the line is expressed in the standard form. So by standard form we mean x minus x1 over say a1, y minus y1 over b1, and z minus z1 over c1, right? So now the direction ratios of the line L are given by the numbers 2, 1 and minus 2, right? So this vector B can now be written as 2I cap by these numbers, right? So this vector B is given by these three numbers, so 2I cap plus j cap minus 2k cap, right? Okay, so now we have obtained this vector B which is parallel to this line L, and this vector B gives the direction ratios of the line L, right? Because in order to find out the angle between two vectors we need to know the direction ratios of the line, right? Okay, now let us come to the direction ratios of this normal vector n, right? So now the drs of the normal vector to this plane pi are given by the coefficients of x, y and z, right? So the coefficient are given by 1 because here we have 1x, then we have minus 2, and in this case we have k, right? And we have to find the value of this k, right? So here we have k. So now this normal vector n can also be written as I cap minus 2j cap plus k and k cap, right? So this k cap is the unit vector along the z direction. So now the situation is like this, right? So we have this normal vector, and this is the line L which is shown here, and this is the angle 90 minus theta which is denoted by phi, right? So now we have two vectors. Now this line L is equivalent to this vector B because this line L is parallel to this vector B, right? So we can also take this vector as vector B, right? So now the problem is to find the angle between these two vectors, right? So now we know that from vectors the dot product of these two vectors, that is vector n dot vector b, is equal to the magnitude of vector n, the magnitude of vector b, and cos of phi, right? So this is the definition of the dot product or the scalar product of two vectors, right? So the angle between these two vectors can be obtained by taking the dot product of these two vectors, right? So now we have cos phi is equal to vector n dot vector b and divided by the magnitude of vector n and the vector magnitude of vector b, right? So this is the formula for calculating the angle between a plane and a line. So viewers, always remember that if we are to find the angle between a line and a plane, then we use this formula, right? So cos phi is equal to the normal vector and the vector which is parallel to the given line. So we'll take the dot product and then we'll divide the this dot product by the product of the magnitudes of vector n and this vector b, right? So now let us calculate n dot b, right? So n dot b is given by, see here we have 1 I cap minus 2j cap plus k and k cap, and we have this vector b 2I cap plus j cap minus 2k cap, and we know how to calculate the dot product of two vectors. So we'll multiply the I components, then j components and k components, and then we'll add the three numbers, right? So we have 1 here, and then we have 2, then we have minus 2 here, and then here we have 1 because this is 1 j cap, and then we have k here, and here we have minus 2, right? So now this is 2 minus 2, this is 2 minus 2 minus 2k, and this 2 and this 2 get cancelled, so we are left with minus 2k, right? So now let us calculate the magnitude of vector n, right? So magnitude of vector n is equal to square root of 1 square, then we have minus 2 square, and then we have here k, so we have k square, so this is 1 plus 4, and here we have k square, so now we have square root of 1 plus 4 is 5 plus k square, right? So now the magnitude of vector n is square root of 5 plus k square, right? Okay, so now let us find the magnitude of vector b. So the magnitude of vector b is square root of, see here we have 2, 1 and minus 2. So this is 2 square plus 1 square, and then we have minus 2 square. So this is square root of 4 plus 1 5, and 5 plus 4 9, so square root of 9, which is equal to 3, right? So the magnitude of vector b is equal to 3, right? So now let us substitute these values in this formula. So we have cos of phi, and phi is equal to 90 minus theta. So vector n dot vector b is minus 2k, then we have square root of 5 plus k square, and then here we have 3, right? Okay, so now see, we have cos of phi is equal to minus 2k over 3 times square root of 5 plus k square, right? So now viewers, let us substitute the value of phi, which is 90 minus theta, where theta is the angle between this line L and the plane pi, right? So cos phi, which is cos phi is equal to cos of 90 minus theta, and cos 90 minus theta is sine theta, right? So now sine theta is equal to minus 2k over 3 times square root of 5 plus k square, right? So what we have done here, we have the expression for cos phi, where phi is the angle between the normal and the line L, and phi is equal to 90 minus theta, and we have cos phi is equal to cos 90 minus theta, that is sine theta. So sine theta is now equal to this expression, and moreover we are given that the angle between this line and this plane is cos inverse of 2 root 2 over 3, right? So it implies that we are given theta is equal to cos inverse of 2 root 2 over 3, right? Because theta is the angle between the line L and the plane pi, and this angle is given to be equal to cos inverse 2 root 2 over 3. So from here we can write cos of theta is equal to 2 root 2 over 3. So viewers, now we have two expressions for theta, right? So the first one is sine theta is equal to minus 2k over 3 times square root of 5 plus k square, and the second one is cos theta is equal to 2 root 2 over 3, right? So now we'll eliminate theta from these two equations to find out the value of k, right? For this what we will do, we'll make use of this result from trigonometry, that is sine square theta plus cos square theta is equal to 1, right? So now the square of sine theta gives us, see here we have minus 2k, so here we have 4k square, then we have 9 here, and 5 plus k square, and here we have 2 root 2 over 3 square, so this is 8 over 9, right? Okay, now we can multiply both sides by 9, so we have 4k square over 5 plus k square plus 8 is equal to 9. And if we take the LCM, because here we have 1, so we can write 4k square plus 8 times 5 plus k square is equal to 9 times 5 plus k square, right? Now simplifying it further, we have 4k square plus 40 plus 8k square, and here we have 45 plus 9k square, right? And this is 12k square minus 9k square, that is 3k square. And if we take 40 to this side, we have 45 minus 40, that is 5, right? So now 3k square is equal to 5, and k square is equal to 5 over 3. So k is square root of 5 over 3, right? So this is the required value of k in this problem, right? So viewers, this is how we solve this problem, and in this class we have also studied how to derive the formula for the angle between a line and a plane pi, right?